Assalamualaikum warahmatullahi wabarakatuh.
Here our STEM education lecturer, Ms. Dr. Yurizka Melia Sari, SPD, MPD, and all my friends, Mathematics Education 2023A, who are watching this video. We are from Team 5, and I'm Khairunnisa Widyananda with last 3 digits number 036.
I'm Olinda Maharani Aqilla Putri with last 3 digit number 121.
And I'm Mochamad Reval Ardhi Prayogo with last 3 digit number 200. We are from Mathematics Education 2023A, State University of Surabaya.
So, today we're going to present and discuss about our project in STEM education in making saving technology innovation. Here, we are going to make an Aerator water faucet technology as STEM integration in learning for junior high school to overcome some problems in SDGs.
Aerator water faucet technology is a smart and eco-friendly feature commonly found in modern faucets. An aerator is a small mesh or device that is attached to the end of a faucet. Its main job is to mix air into the water stream, which changes the way the water flows out.
When water flows through the aerator, the water will be broken into many small droplets, and then air is added to the flow, and the result is a smooth, splash-free, and softer water flow. One of the benefits of using this aerator water is to save clean water to support the SDGs number 6, this is clear water and sanitation.
The first one is about the learning objective. It is known that in this world, there are still many people who don't save clean water, and sometimes like to waste it because they don't even think about the future for their children and grandchildren. So, in this project, we hope that students might pay more attention to the problem of this water wastage for saving clean water. It also hopes that students can think about how to solve this water wastage problem using STEM that learned in this learning activity at school. They can use many disciplines in STEM to make some mini project. In this activity, students are able to work in teams to create a technology or prototype of automatic faucet water saving solution. And also, the students have to evaluate the effectiveness of the solution through testing and improving their prototype.
So, what about the STEM integrated learning, and what is the main subject that we use? For science, the student can learn about the impact of water wastage in the environment and the characteristic of water flow in the water path. For technology, the students can use internet to search for the information about the existing water faucet solution. And for the engineering, the students have to design a modification of the existing water faucet that include aerators. And the last one is the main subject for this project. It is mathematics. In mathematics, the students calculate water discharge before and after the installation of the automatic aerator water faucet technology. Compare the cost of water before and after using aerator faucet, and they can calculate the relationship between the amount of water volume and discharge with the user's hand surface area.
Okay, so which learning model that we use in these learning activities? We are using project-based learning because it encourages students to actively explore real-world problems and develop practical solutions. By learning about Aerator water faucet technology through these projects, students can understand how STEM is used in daily life, especially in saving water and protecting the environment. This method helps students think creatively, solve problems, and work together in teams. They can also practice making or testing their own water-saving faucet models. Therefore, through this project, students become more active in learning and realize that learning STEM can help them to solve real-life problems.
Okay, which approaches that we use? Problem-centric, user-centric, or solution-centric? In this project, we are using solution-centric approaches because it helps students focus on making something to solve the real problems. This problem already has a solution, like using a usual aerator faucet technology. However, this existing solution still has some weakness or limitation, like it can get blocked easily by dirt or mineral in the water. So it makes the water flow slower and the aerator needs to be replaced regularly. Through this approach, students are encouraged to improve the current solution by finding better ideas or making it more effective. This helps them learn how to think critically and make real improvement to existing technologies.
So here, what we use, ADP or DT. Of course, we are using the ADP or engineering design process because it helps students solve problems step by step, just like real engineers. This approach emphasizes technical solutions to address problems. This approach also teaches them how to understand a problem, find a solution, test it, and make improvement. It is also helps students think carefully, be creative, and learn from their mistakes. By using ADP, students can design better solutions and see how their ideas can be used in real life. The cycles of ADP first is ask or inquire about user problem and needs. Here, like what are the main problems with using water faucet today? Who are the users and what are their housing habits? And is there a way to make the faucet only turn on when it is really needed? Second is research or collecting information and inspiring solution. Here like find out how existing automatic faucet work, research sensor technology as like motion, color, temperature, and humidity, and investigate water usage data and the effectiveness of aerators in saving water. Third is imagine a possible solution, which is here a brainstorm tool idea. For example, faucet will with 30 hand detection sensors, the use of LED indicators, and water saving alarm system, and comparing idea based on cost, functionality, and simplicity.
Okay, next is plan. Make a design and work steps. Here, students develop a design of their version of the automatic faucet and determine the component needed like sensors, aerators, and other. And next is create or build prototypes according to plan. Here, students incorporate sensors and automatic water flow system and record the manufacturing process for documentation like photo, videos, or diagram. Next is test or testing the performance of the tools that have been made. Here, student testing the faucet with dirty versus clean hands and measuring how much water is used and checking sensor response to hand condition and device reaction time. And the last one is improve or revise and improve the design based on the pilot test results. Like analyze the weakness of a device. Is the sensor sensitive or is the aerator working optimally? Make minor improvement like strengthening connection, resetting sensors, or replacing component, and make suggestion for long-term development.
Okay, let's discuss about the learning syntax in our project of STEM. From the meeting 1. Meeting 1 is problem identification and project planning. Activity 1 is introduction. Students share their experience or habits related to water usage, and students write their opinion about the importance of saving water. And then activity 2 is determining the fundamental equation. Students discuss to find the weakness of the existing solution, and then students collaborate in group to formulate the project question. As how to design a water-saving faucet with a dirty hand sensor. And then students identify project success criteria, efficient, effective, water-saving. And then students formulate group goals based on the problem found. Okay, in activity 3 is planning a project. Students make an initial sketch of the tool design based on group ideas. And then students determine the tools and materials needed to make the prototype.
Okay, next activity 4, planning a schedule. Here, students develop a project implementation schedule with the group, and students divide the roles and responsibilities of group members, and students agree on the time for data collection and tool making. And last one, for the meeting 1, activity 5 is conclusion. Here, students present their project ideas and plans in front of the class, and then students receive and record feedback from the teacher and other groups, and students refine the project plan based on the feedback.
And next to the meeting 2. In meeting 2 is project implementation and evaluation. Activity 1 is introduction. Here students review the design and plans from session 1 or from meeting 1. And students prepare tools, materials, and workspace to make the prototype. And students review their roles in the project implementation. Activity 2 is monitoring students and progress of the project. Here students document the manufacturing process with photos or video, and they're discussed to solve technical problems or design adjustments. Activity 3 is testing the prototype. Here, students test the prototype to see if the sensor works as expected. Students measure the volume of water used when the device is working and when it is not. And students record the test result into a table and make data comparison.
Okay, activity 4. In activity 4 is evaluating the experience. Here, students reflect on the success and shortcomings of the prototype. And then students prepare a final project report that includes the process, data, and solution. And then activity 5 is conclusion. Here, students present the project result and analyze data in group presentation.
Okay guys, so I think that's all from us. We're so sorry if there are a lot of mistakes because we are still learning too. Thank you so much for our lecturer, Mrs. Dr. Yurizka Melia Sari MPD, and all my friends who are watching these videos.
Wassalamualaikum warahmatullahi wabarakatuh.
Bye-bye. See you guys.
See you.